Let knowledge flow like a river, without any hindrance. Don't make it like a stagnant pool. Hi everyone. I'm PS Chatterjee, and I'm excited to have you join me again for another Excel adventure. Today, we're diving deep into advanced statistical functions, specifically forecasting and trend analysis. As you can see on our slide, we'll be using Excel to explore powerful techniques like SKEW and KURT to understand data distribution and predict future trends. This is part of our Excel Intermediate Part 5 series, so let's roll up our sleeves and get started. Remember to like, share, subscribe, and leave a comment below. Your support means the world to me. Let's unlock the potential of these amazing functions together. In this session, we'll explore powerful techniques in Excel to predict future trends and make informed decisions. For forecasting and trend analysis, it's essential to have a clear understanding of the term SKEW. Now, let's delve into the concept of SKEW and its implications for data analysis. We'll then apply these insights to various forecasting methods. Overview. We'll start by understanding the concept of SKEW, a measure of the asymmetry in a distribution. In a zero-skewed distribution, the data is evenly distributed around the central point, and the mode, median, and mean are approximately equal. In a positively skewed distribution, the tail on the right side is longer, while in a negatively skewed distribution, the tail on the left side is longer. Mode, median, mean. Remember the relationship between these three measures in different types of SKEW. In a positively skewed distribution, the mean is greater than the median, which is greater than the mode. In a negatively skewed distribution, the order is reversed. Forecasting methods. Time series analysis. One of the most common forecasting methods is time series analysis, which involves analyzing data points collected over time. Moving averages. Moving averages smooth out fluctuations in data and provide a trend line. We'll explore simple, weighted, and exponential moving averages. Exponential smoothing. Exponential smoothing assigns more weight to recent data points, making it suitable for data with changing patterns. ARIMA models. ARIMA or autoregressive integrated moving average models are used for more complex time series data. Practical examples. Let's apply these techniques to real-world examples. We'll forecast sales for a product using historical data and different forecasting methods. Additionally, we'll analyze stock market data and use forecasting models to estimate future prices. In this slide, we're exploring the probability density function curve, PDF. This bell-shaped curve is formed by connecting the average values of different data sets. The height of the curve represents the likelihood of finding data points in different areas. A taller middle part indicates a higher probability of finding data points near the center, while a wider bottom part means there's a higher probability of finding data points spread out. The peak of the curve represents the mode or the most probable value. The y-axis shows the probability density, while the x-axis represents the variable being measured. By understanding the PDF, we can gain valuable insights into the distribution of our data and make informed decisions. In this slide, we're exploring the concept of kurtosis, a statistical measure that describes the tailedness of a probability distribution. Definition of kurtosis. Kurtosis measures how much of a distribution's data falls in the tails relative to its center. It helps us understand the concentration of extreme values or outliers. Types of kurtosis. Generally we can divide the kurtosis in three categories. 1. Leptokurtic, or high kurtosis. 2. Mesokurtic, or medium kurtosis. And 3. Platykurtic, or low kurtosis. Leptokurtic. This distribution has heavy tails, meaning there are more outliers or extreme values. The distribution appears more peaked than a normal distribution. Mesokurtic. This refers to a distribution with medium kurtosis, similar to a normal distribution. Platykurtic. This distribution has thin tails, meaning there are fewer outliers. This slide illustrates the concept of a probability density function, PDF, specifically the normal distribution. A PDF is a mathematical function that represents the probability distribution of a continuous random variable. In a normal distribution, the data points are clustered around the mean, forming a bell-shaped curve. Figure 1 shows a normal distribution with 68% of the data falling within one standard deviation of the mean. This means that 68% of the observations in the dataset will be within one standard deviation above or below the average value. Figure 2 expands on this, showing that 95% of the data falls within two standard deviations of the mean. This indicates that most of the data points are concentrated within a relatively narrow range around the average. Figure 3 further demonstrates the concept, revealing that 99.7% of the data lies within three standard deviations of the mean. This means that almost all of the observations in the dataset will be within this range. Understanding the PDF is crucial in statistics and data analysis as it helps us visualize the distribution of data, identify outliers, and make informed inferences about the population. This chart illustrates a time series analysis, where we're tracking the price of a share over a year. The blue line represents the actual share price, while the red line is a trend line fitted to the data. Trend analysis. The trend line provides a general direction of the share price over time. In this case, it appears to be upward, suggesting an increasing trend. This trend line is calculated using statistical methods, such as linear regression, which fits a straight line to the data points. Forecasting. Once we have established a trend, we can use it to make predictions about future values. The arrow with magenta color in the chart represents the forecasted share price for the next month, December. This forecast is based on the assumption that the historical trend will continue into the future. Important considerations. Accuracy. Forecasting is not always perfect. The accuracy of the forecast depends on how well the trend line fits the data and whether there are any significant factors that could affect the future price. Time horizon. Forecasting is generally more accurate for short-term predictions than for long-term predictions. Other factors such as economic conditions, industry trends, and company-specific news can also influence the share price and may not be fully captured by the trend line. By understanding trend analysis and forecasting techniques, we can make informed decisions and anticipate future developments in various fields, including finance, economics, and business. This slide introduces the small and large functions, Two essential tools for data analysis in Excel. These functions allow you to extract specific values from a data set based on their rank. They are particularly useful when you need to identify the smallest or largest values in a range of data. Small function. The small function returns the kth smallest value in a data set. Syntax: small, array, k. Array: the range of cells containing the data. K: the rank of the value you want to return. Example: if we have an income distribution data set in row 2, from column A to column K, and we want to find the second smallest income, we can use the formula equals to small a2k2 2. Large function. The large function returns the kth largest value in a data set. Syntax: large, array, k. Example: to find the third largest income in the same income distribution data set, we would use the formula equals large a2k2 3. Common uses: finding outliers, identify extreme values in the income distribution. Calculating percentiles, determine specific income levels within the distribution, such as the 25th, 50th, or 75th percentiles. Ranking incomes, sort the incomes from lowest to highest. Welcome back to Excel Intermediate Part 5. In this session, we'll delve deeper into powerful statistical functions and their practical applications. We'll revisit concepts like mode, median, mean, SKEW, KURT, step, small, large, trend line, and forecasting using 3 data sets to understand various distribution patterns. Let's start with our first data set. In rows A3 to K3, we have data points 1 to 11. In rows A4 to K4, we have a set of income values ranging from 30 to 85 lakhs per year. Notice that the values 55 and 55 appear twice in the data set under data points 6 and 7. This means the mode, or the most frequently occurring value, is 55. You can see the mode value in cell L4, calculated using the formula equals mode A4K4. If we change the value of data point 7 from 55 to 51, the mode will become #n/A, indicating that there are no repeated values in the data set. The cells of the 6th data point are filled with yellow color to highlight the median value. Now, let's explore some additional statistical functions that are essential for data analysis. Median. To find the median value, we use the median function. For example, equals median, A4K4, calculates the median of the income data in cells A4 to K4 and the value is 55 on the cell M4. Mean. The average value is calculated using the average function. So, equals average, A4K4, gives us the mean income and the value is 55 on the cell N4. Skewness. The skewness of the distribution is determined using the SKEW function. Equals SKEW, A4K4, calculates the skewness of the income data and the value is 0.26 on the cell O4. Kurtosis. To measure the kurtosis, we use the KURT function. Equals KURT, A4K4, calculates the kurtosis of the income data and the value is -0.82 on the cell P4. Standard deviation. the standard deviation is calculated using the stdef.p function. Equals stdef.p, A4K4, gives us the population standard deviation of the income data and the value is 16.51 on the cell Q4. Small, to find the kth smallest value, we use the small functions. For example, equals small, A4K4, 2, finds the second smallest value, and the value is 35 on the cell R4. Large, to find the kth largest value, we use the large functions. For example, equals large, A4K4, 3, finds the third largest value and the value is 70 on the cell S4. Now we have to insert the standard deviation curve. To do that, we have to follow the following points. Step 1. First we have to select a scale factor. Since maximum standard deviation is restricted to +3 or -3, suitable scale factor may be assumed as value of standard deviation divided by 3. Here value is 16.51, so I am considering 16.51 by 3 equals 5.505. Scale factor should be greater than or equals 5.505. I am considering the scale factor as 10. Step 2. Creating the coordinate system. To visualize the standard deviation curve, we'll first create a coordinate system. In the x-axis, we'll plot the data points from 0 to 170 in increments of 10. Step 3, the y-axis will represent the probability density, which we'll calculate using the normal distribution function. The norm.dist function is used to calculate the probability density of a value in a normal distribution. The function takes 4 arguments. X, the value for which you want to calculate the probability density. Mean, the mean of the distribution, which in our case is the value in cell N4. Standard_dev, the standard deviation of the distribution, which is the value in cell Q4. Cumulative, a logical value that determines whether to calculate the cumulative probability or the probability density. For our curve, we'll use false to get the probability density. To apply this function to our data set, we'll enter the formula equals norm.dist, B6, $n $4, $q $4, false, in cell B7. Here, we're locking the mean and standard deviation cells, N4 and Q4, using the F4 key to ensure they remain constant as we copy the formula to other cells. Step 4, creating the chart. To create the standard deviation curve, we'll use a scatter chart with a smooth line type. First, let's hide rows 2 to 5 to provide more space for the chart. Now, select the data range from cells B6 to S6, which contains the x-axis values and the corresponding probability densities. Go to the Insert tab and select the scatter chart type. Choose the scatter chart with smooth lines to create the standard deviation curve. Customize the chart as needed by adding labels, titles, and adjusting the axes. You can also format the curve to match your preferred style. For more in-depth customization options, refer to my previous video, Mastering Charts and Graphs, Excel for Beginners Part 6. Now that we've calculated the standard deviation for our data set, let's visualize its implications using a standard deviation curve. This curve, also known as a bell curve or normal distribution, helps us understand how data points are distributed around the mean. Understanding the curve, the standard deviation curve is symmetrical, with the peak representing the mean value. The shape of the curve is determined by the standard deviation. A smaller standard deviation means data points are clustered closer to the mean, resulting in a narrower, taller curve. A larger standard deviation indicates data points are more spread out, leading to a wider, flatter curve. Relating standard deviation to the curve, the standard deviation is directly related to the width of the curve. One standard deviation from the mean encompasses approximately 68% of the data points. Two standard deviations from the mean include about 95% of the data points, and three standard deviations account for almost 99.7% of the data. Analyzing the curve, by analyzing the standard deviation curve, we can gain valuable insights into the distribution of our data. For example, a highly skewed distribution will have a curve that is not perfectly symmetrical, with a longer tail on one side. A kurtotic distribution will have a more peaked or flat-tailed shape compared to a normal distribution. From our data analysis, we found that the mode, median, and mean are all equal to 55. This indicates a symmetrical distribution of the data. Additionally, the skewness function value is 0.26, which suggests a slight positive skew. However, given the small value of 0.26, we can consider the skewness of this curve to be approximately 0. The combination of a 0 skewness value and a kurtosis value of -0.82 indicates a mesokurtic distribution. In a mesokurtic distribution, the peak of the curve is moderately sharp, and the tails are neither excessively long nor short. This suggests a relatively normal distribution with some slight variations. Therefore, based on our analysis, we can conclude that the data distribution is approximately normal, with a slight positive skew and a moderately sharp peak. In this segment, we'll demonstrate how to create a trend line and perform forecasting in Excel. A trend line is a visual representation of the overall trend in a data set. It can help us identify patterns, make predictions, and understand the relationship between variables. Step 1. Selecting the data. Begin by selecting the data points that you want to analyze. In this example, we'll select the data points represented by the blue curve. Step 2. Adding a trend line. To add a trend line, click on any data point within the series. This will highlight the entire series. Right-click on the selected series and choose Add Trend Line. A dialog box will appear. In the Trend Line Options tab, select the type of trend line you want to use. For this example, we'll choose a linear trend line since the data appears to follow a straight line pattern. Check the Display Equation on Chart and Display R-squared value on Chart options to see the equation and R-squared value of the trend line. These values help assess the goodness of fit of the trend line to the data. Step 3. Forecasting. Once the trend line is added, you can use it to forecast future values. Right-click on the trend line and select Format Trend Line. In the Forecast tab, specify the number of periods you want to forecast into the future. For example, if you want to forecast the next 5 data points, enter 5 in the Forward Periods field. Click Close to apply the forecast. Excel will extend the trend line and display the forecasted values. By creating a trend line and performing forecasting, you can gain valuable insights into the underlying trends in your data and make informed predictions. Remember to experiment with different trend line types to find the best fit for your specific data set. If you'd like to learn more about other trend line types, such as polynomial or exponential, please leave a comment below, and I can create a separate video on that topic. In this segment, we'll delve into a large-scale data distribution and analyze its characteristics using statistical functions and visualization techniques. This is our case 2. The data set for this analysis includes the following values. In this data set we have 11 data points and the data values are as follows: 20, 30, 60, 80, 80, 100, 100, 200, 400, 300 and 500. By calculating the mode, median, mean, skewness, and standard deviation, we can gain insights into the data distribution. The calculated values are: mode, 80, median, 100, mean, 170, skewness, 1.189, kurtosis, 0.22, standard deviation, 153.68, smallest value, 30, largest value, 300. Interpreting the results. Since the mean is greater than the median and the median is greater than the mode, we can conclude that the curve is positively skewed. This indicates that the majority of the data density is on the right side of the mean. The kurtosis value of 0.22 suggests a mesokurtic distribution. This means the peak of the curve is moderately sharp, and the tails are neither excessively long nor short. To visualize the data distribution, we've created a standard deviation curve. The x-axis represents the data points, and the y-axis represents the probability density. The curve is generated using the same principles we discussed earlier, where the standard deviation determines the shape of the curve. The shape of the curve confirms the right skewed and mesokurtic nature of the distribution. This suggests that the data is skewed to the right, with a moderately sharp peak. In this segment, we'll examine a stock daily return percentage distribution and analyze its characteristics using statistical functions and visualization techniques. This is our case 3. The data set for this analysis includes the following values: minus 3.0, minus 2.0, minus 1.0, 0.5, 0.5, 1.0, 1.5, 2.0, 2.0, 2.5, and 3.0. By calculating the mode, median, mean, skewness, and standard deviation, we can gain insights into the data distribution. The calculated values are: mode, 0.5, median, 1.00, mean, 0.64, skewness, minus 0.793, kurtosis, minus 0.308, standard deviation, 1.823, smallest value, minus 2.00, largest value, 2.00. Interpreting the results. Since the mean is less than the median and the median is less than the mode, we can conclude that the curve is negatively skewed. This indicates that the majority of the data density is on the left side of the mean. The kurtosis value of minus 0.308 suggests a mesokurtic distribution. This means the peak of the curve is moderately sharp, and the tails are neither excessively long nor short. Visualizing the distribution. To visualize the data distribution, we've created a standard deviation curve. The x-axis represents the data points, and the y-axis represents the probability density. The curve is generated using the same principles we discussed earlier, where the standard deviation determines the shape of the curve. The shape of the curve confirms the left skewed and mesokurtic nature of the distribution. This suggests that the stock daily return percentages are skewed to the left, with a moderately sharp peak. Understanding the standard deviation curve is crucial for interpreting data and making informed decisions. By analyzing the shape and characteristics of the curve, we can assess the variability of our data and identify outliers or unusual patterns. Thank you for watching this tutorial on advanced statistical functions in Excel. We explored SKEW, KURT, forecast, trend, small, and large, and their applications in forecasting and trend analysis. Remember to practice these functions and experiment with different data sets to solidify your understanding. If you found this video helpful, please like, share, and subscribe to our channel for more Excel tutorials and tips. Until next time, happy analyzing.